Now we will create a project that have a service. We can call this service to use the segmentation neural network to create semantic image or to predict the shape and return for the color the semantic image. To do that, firstly we have to create a folder SRV, and we create a service message. It has an input and the output here. We can have many input and have many output. Input is the upper part, and this is the lower part for the output. Here we use sensor message image. It is a standard message was defined in rows. And then we have to change the semantic list to generate a service message. We have to add here the message generation packet. Okay, and go down. You should open this. In previously it was closed by this tag, but you should open and add the service file here, and this general message open and add this message. In the packets XML, we should add two packets here: view depend and execute depends, message generation and message runtime. Okay, after you add this and change the, after you add the message, define the SRV, change the semantic list, change the packet, you should rebuild the catkin ws folder by run the command catkin make. And after finish this command, we will generate a library, like the heading file for the for the service. And then we create a file in script folder like save service here. After we finished running, we have this thing. We have a rich image back.srv. That means we can use the service message to send, and we have to import this to use. So that is a service written in Python because we use the develop mobile develop. So we have import touch touch vision transform and develop numpy OpenCV. Okay, first we go from the main. Firstly we will init the node sub node. Okay, and then we create new model. It's like the previous program, the predict program here. We create the model and we predict the image, create semantic image. We create new model and we load the weight, and then we start new node with the service, and I define the node here as a class and look into the init function, it will automatically called when we declare an object of this class. In this class we have RGB, we have a depth, we have semantic image, and that first is none. And then we create a CV bridge to copy the image from the message. And we declare a roast service. Has the name is the RGB step model. And we use the message to send to service message to send between call and response is the step is the RGB image which we include from this library. And the callback function is the function handle the call service is a handle RGB step service. This predict function is similar to our previous function. This is the handle service. This is the request, include the service request. Firstly, we copy the image from the request. This is an RGB image. And then we change to, because we read image by OpenCV as well in entire BGR, and we have convert to RGB to fit to suitable with our model. So, and then we call the predict function and return a semantic image. This is a because we colorize the image here, so this is a semantic image, not the mask. And then we create a image message, and we return for the service here by this command RGB response. So that's we will return the semantic image. The function star just called roast b to make the not available all the time. This is for create a service server to waiting the request about changing the RGB to semantic image. And now we will create the client where we'll call this service. Go back to the 3D CPP. We have did before to display RGB point cloud. We have a RGB point cloud log image store 3. And next, what we do, roasting it is always called because before you doing something related to roast, declare a node handler and declare a client service. This client service will use the RGB image service message, and this will call the RGB step model, which is defined in subservice.py here. We say RGB step model, and this called RGB step model. Then we define a message with the image is the RGB of the point cloud. Okay. And then we call the service, and this service will return the semantic image as a roast message, and we will copy the image to the point cloud object, and we call the show semantic image 3D. It's the same as our function to create color point cloud, but this is different that we don't use RGB to create point cloud, but we use the semantic image, and in this function we remove the black point to decrease the number of points here. We can create semantic point cloud, and this is a semantic image. In previous function we create point cloud, but the input the RGB. Now the input is semantic image. After that we call the visualize to minimize, to decrease the number of points. So that's all. So now we will try to run this. Firstly we have to start there's something wrong. I should change the depth scale. Okay, the depth scale in light 1, 2, 3. Okay, the depth scale. Depth scale. That's the wrong name. Okay, good. I will run again. As change a little for previous function is that I change this parameter to the class attribute, because we're using the many times. I don't want we declare and it's too much. Previously it was here, but I'm remove and put it as like global variable or the attribute of the class. And now we wait until it's finished. And as I told you, we have to because we have a service server and service client, and when to use this function you have to call the service server first. By the way, in the Python file you should use this line to indicate which version of Python you want to use. For example, here this we have a Python 3.9, Python 3.8, Python 2.7, and I indicate I use the user beans Python 3. So I do this command, and somehow the Python file is not executable file. You must change by this. Go to this folder, script, and right click, property, permissions, and check to this allow executing file as a program. Okay, then it's finished. We will start a roast bucket and the Python file. We will start service, and then we call the node read image 3D back node. Yes, we have a colors image here, tab image here, the 3D point cloud here, and I will click, and we have a semantic image here, and now we have a semantic point cloud here. Okay. That's not